So, should we start?
Yes.
So, welcome to the second day of our workshop on data simulation and uncertainty quantification at the ExCALIBUR. Today on uncertainty quantification. In the first day, Garth introduced the working group funded by EPSRC, the ExCALIBUR Computing for System Level Engineering. And today we are talking about UQ, or uncertainty quantification. So nice series of talks. I noticed in the talks that we are going to discuss faster or better surrogates and the benefits that we expect at the exascale using new methods or software or hardware. Obviously multi-scale or multi-fidelity modeling, multi-level for some of us, multi-physics and multidisciplinary models, mixing physics, mixing disciplines is also a big challenge for UQ at the exascale. And one of the components or pillars of the ExCALIBUR program is the involvement of software engineers, the research software engineers, the RSEs. And we listen to a few talks about workflows in particular. And high dimensions is also an issue and will be discussed in some of the talks today. Obviously, the larger, the more complex, and maybe we should think about memory management and algorithms that scale well. And yesterday, at the end of the day, we realized that many of the data simulation speakers addressed the issue of merging DA with UQ, employing surrogates in particular. And some concrete UQ challenge for the rest of the day and the future. So we discussed yesterday with Riken, who was represented by Takemasa Iyoshi, the Fugaku, the supercomputer #1 in the world now. The idea that you could go top down, you could have priority issues and exploratory challenges. So that's the way they structured their next steps. But we could also employ an open bottom-up strategy of calling for projects and mixing scientists and computer scientists in these projects. That's the next point, actually, the fact that we need teams of computational or domain scientists or data scientists and mathematical scientists and statisticians, as well as RSE. So this is just one example, but I'm sure people involved in other networks and other projects have the same combination. So this is the people in my team here at Turing. So we have colleagues from computational sciences, we have domain scientists, we have several RSEs and statisticians. So this is probably the way to succeed with the exascale for UQ. But I'm happy to listen to other ideas, other formats. And the last point I want to raise before we start is, well, how do we get to exascale? Not only in terms of hardware, but in terms of processes and even learning processes, or training or access for us scientists or data scientists. From the university level, the tier 3, the regional specialized level at tier 2, to the tier 1 and 0 that may be at the exascale. So these are my 3 slides for today. But obviously the speakers will have much more to say and much more concrete ideas. So let me introduce first